Ladies and gentlemen, today we are excited to introduce our Capstone project, Frutify, a solution designed to empower vulnerable communities for health and well-being. Let me introduce our team. I'm Fiona, and with me are Indri and Stacy for machine learning, Jojo and Raisha for cloud computing, and Raihan for mobile development. In the next 10 minutes, we will cover the following key points. To begin, let's dive into the background of our project. I will take you through this section. Food waste is more than just scraps left on your plate. It's a crisis we cannot ignore. In Indonesia alone, 23 to 48 million pounds of food are wasted annually. This translates to 115 to 184 kilograms per person every year. Financially, that's a loss of 213 to 551 trillion rupiahs annually. But the impact goes far beyond money. The energy wasted in producing this discarded food could provide a meal for 61 to 125 million people. And that's millions of opportunities lost to improve nutrition and health, especially in vulnerable communities. This brings us to a crucial point. Eating more fruits and vegetables is one of the simplest ways to maintain a healthy diet and prevent chronic diseases. In fact, insufficient fruit and vegetable intake has been identified as a major cause of death for both men and women. But sadly, 95.4% of individuals aged 5 and older in Indonesia fail to consume the recommended amounts of fruit and vegetable. With these facts in mind, in the next slide, we'll explore how Frutify aims to address it.
Hello everyone, I will explain the purpose of our app. Our team was inspired to create this project after realizing that some people do not know about the nutritional content of the fruit, how to store and care for fruit properly, and the quality of freshness of the fruit. For the reason, we talk of creating an application that can determine when is the right time to consume fruit, to take the level of freshness or take sign of disease in fruit, as well as provide tips and guidelines for overcoming problems or disease in fruit. The app provides suggestions for proper storage, optimal consumption timing, and nutritional information about fruits. It also includes recommendations for fruit pairing to support the user health goals. This app aims to improve overall diet health and contribute to reducing for food waste in Indonesia.
Alright, for the next slide, which is to explain about existing results. So far, existing studies and efforts related to our product are firstly, freshness detection technologies. Several studies have explored the use of sensors and imaging technologies to assess the freshness of fruits, which is also the basic of Frutify's freshness detection feature. The second one is about application related to nutritional awareness of food consumed, such as like MyFitnessPal and Yuamli, which is focused on nutritional information on food consumed by consumers. But Frutify could integrate similar feature, but with a special emphasis on fruits to increase users' knowledge on their nutritional benefits. For the missing element, here on personalization usually concern personalized recommendation. While the current app provides general information, there are no personalized recommendations based on individual preference and local fruit availability. And also, for the integration with smart device, while there is potential for Frutify to integrate with smart kitchen device, allowing real-time monitoring of freshness and alerts when fruits are about to spoil.
Okay guys, here we will discuss about the implementation part. Here we will discuss the implementation of the three learning paths. Namely, the first is machine learning, cloud computing, and the last is mobile development. Okay, well, we enter the first discussion, which is the implementation by machine learning's learning path. The tools used in Cloud Kaggle. In our project, is used as the main source for collecting fruit-related datasets needed to train machine learning models. And the second is Google Colab. This tool is used to train and experiment with our machine learning model Colab relatively and efficiently. Then the third tool is TensorFlow. For this project, TensorFlow is utilized to create a fruit condition detection model, thus enabling process classification and prediction. Then, next we will discuss about cloud computing's implementation. The tool's first is Express.js. In this project, it serves as the core for creating and managing server-side logic, allowing seamless communication between the front end and the database. The second tool is Google Cloud SQL, used in our project to securely store and manage user data and Fruit scan results. The third tool is Google Cloud Storage, to store Fruit image uploaded by users, ensuring reliable and scalable file management. Then the fourth tool is a Postman. Postman used to test our API endpoints, verify their functionality, and debug any potential issues. We'll move on to discussing the implementation of mobile development learning path. The tools used include the first is Kotlin. Kotlin is the main programming language used to develop our application, Frutify. The second tool is Jetpack Compose. In Frutify, Jetpack Compose is used to design a clean and intuitive interface where users can upload Fruit image, view nutritional details, and navigate smoothly through application features. Then, there is the retrofit library. For Frutify, retrofit handles tasks such as uploading Fruit image to the cloud for analysis, retrieving nutritional information based on scan results, and retrieving user upload history. Then there is the Camera X library. In Frutify, Camera X is used to check high-quality image of fruits, ensuring accurate analysis for condition detection and nutritional assessment. Then there are the live data and view model libraries. In Frutify, these components are used to manage user scan history, nutrition data, and camera interaction, ensuring a smooth and responsive user experience.
Next, I will explain and present the result of the Frutify application that we built. When the user opens the Frutify application, user will be directed to the onboarding page first. On this onboarding page, a welcome greeting is displayed, which is accompanied by a little explanation of the use of the Frutify application. This onboarding page contains 3 steps that we can see together in the screen. After the 3 steps on the onboarding page are successfully paced, user can press the Get Started button to start using the Frutify. Next, the user will be directed to the login page. Here, the user can enter an email and password. If the user does not have an account, then the user must create an account first by pressing the Register button. On the Register page, the user must fill in the full name column, email, and the password column, and if all 3 columns are filled in, then it means that the user account has been successfully created and can return to the login page and enter the email and password that was created earlier. After the user has successfully logged in, the user will be directed to the home screen page. On this page will be displayed a choice of 8 types of fruit that can be checked for freshness, including apples, orange, bananas, tomatoes, cucumber, strawberries, peaches, and pomegranates. Besides that, on the home screen page, there is also recent data from fruits that have previously been checked. Here, all the checking history will be saved and can be seen again at any time when the user wants to see the checking history. Then, the user can choose one type of fruit to be checked for the freshness. Then, user will be directed to the scan page, which can be seen on the screen. Then, if the fruit that is checked is fresh, it will display the output in the form of fresh, and the user can save the result of the check. But if it turns out that the fruit that is checked is not fresh, it will display the output not fresh, and the user will be directed back to the scan menu at the beginning. Next, from the result of checking the fresh fruit that has been stored earlier, the user can enter the weight of the fruit and the date of checking. Later, the data from the fruit is successfully stored. The user will get information in the form of nutrient that will be obtained if the user has consumed the fruit. On the screen is displayed a history page that can be viewed by the user. Besides that, there is a setting menu which contains personal information, change password, language, the on-off button, notification, and delete account. If the user presses the personal information button, the user will be directed to a page containing the user's photo, name, gender, email, and password of the Frutify application user. Here, the user can change the user's photo and genders as desired. Then, if the user presses the Change Password button, The user will be directed to a page where the user can change the password of their account. Then, there is also a language menu in settings, where user can change the language of the Frutify application from English to Indonesian and vice versa. Finally, user can delete their account. If the user deletes the account, all data including profile information, notes, and history will be permanently lost and cannot be recovered. But if the user has finished using the application, the user can log out without having to disappear all existing data. User can be logged in back in any time using their email and the password.
For the documentation of the application we have built, you can access it through the GitHub repository we have provided here. Moving forward, we have outlined our plan for next 6 months, which are divided into 4 distinct phases. The first phase is localize the application, conduct testing with 50 until 100 users, establish customer support team, and from initial partnership with local supplier, design early marketing strategies, including teasers and promotion. The second phase is we launch the app on the Google Play Store with an intensive marketing campaign through press release, influencer collaboration, and community partnership. And then the third phase is focusing on user growth through referral programs, local collaboration, and improving server infrastructure, analyze user data to develop new features, and including multi-language support. And the last phase is conduct app performance evaluation, design monetization strategies, and prepare feature updates based on user feedback for long-term growth. In this project, we have also incurred some expenses to enhance our productivity in developing the application. This includes costs for infrastructure, tools, and other necessary resources, such as infrastructure for Google Cloud, ML machine learning service, deployment like Play Store, marketing, and design tools like Figma Pro. To conclude, we are excited about the future of this project and the impact it will have. We believe the steps we have outlined, the investment we have made will lead to a successful product that solves real-world challenges. Thank you for your attention and support.